All right, so let's do another. All right, so let's find, switch pins. dy dx for 3x squared plus 2y plus xy squared equals 4. So again, we're trying to find the derivative of y with respect to x, y prime. But again, see, this is not going to be an easy one to get y on the side by itself, so we are going to use the implicit differentiation here. And so again, what you first do is just d dx both sides. So I won't have to write again, but I'm just d dxing both sides. Now, d dxing the left side here, well, the adding part, that's just going to mean do the derivative with respect to x of that, which would be 6x. The derivative with respect to x of that, what would that be? Derivative with respect to x of 2y. Yeah, the power rule part of it, I guess you might say, is just 2, isn't it? Because the y would go away. However, it is a y. So what else do I need? Anytime you do the d dx of a y thing, you got to have the dy dx. So yeah, 2 dy dx would be the derivative of that. Now what have I got on that one, though? Well, that was a product, yeah. So you've got to use the product rule to get the d dx of this. It would be the first times the derivative of the second. Let's just do it this way. Plus the second times the derivative of the first. And then we'll have the d dx of 4. So here's what I've got. I've got 6x plus 2 dy dx. This part, well, again, I've got x times the derivative with respect to x of y squared. So when I do that, what is that going to come to? Be 2y dy dx, wouldn't it? Power rule, but I need the dy dx here because I'm doing the derivative with respect to x of a y thing. Anytime you have that, you need the dy dx. All right, then over here, though, I don't. It's just y squared times the derivative with respect to x. What's the derivative with respect to x of x? It would be 1. And then what about on the right? What's the derivative with respect to x of 4? It's a constant, so the derivative is 0. Okay, let's clean it up a little. 6x plus 2 dy dx plus 2xy dy dx plus y squared equals 0. Now again, what are we trying to do? We're trying to find dy dx. Well, turns out, in this case, I've got 2 terms, if you will, that have dy dx on them. So, would it, if I'm solving for dy dx, wouldn't it stand to reason I would want to move these other 2 to the other side? So let's subtract the 6x and the y squared from both sides. So I'll wind up with 2 dy dx plus 2xy dy dx equals negative 6x minus y squared. Or something equivalent. Now what do you think's next? Well, since I'm trying to solve for dy dx and it's on both of these, it's kind of like factoring it off. Wouldn't I factor off the dy dx? And that would leave me 2 plus 2xy, then in parentheses. With me on that? Pull out the dy dx. then what would I do? Well, that's dy dx times 2 plus xy. So wouldn't I divide by 2 plus 2xy? With me? That will just cancel out. So there's dy dx. It's negative 6x minus y squared over 2 plus 2xy. And so we could find any slope you want. Give me the x and the y, I'll give you your slope. So that's what dy dx is. One of the things it is. Is that okay? All right. Let's try another one. Lots of little things that can happen. All right, so let's say, let's find dy dx for x cosine y plus y cosine x equals 1. Same drill. Y equals, that's going to be hard to come by. So I don't want to do that. I'm going to use this implicit differentiation where I don't have to get y equals whatever. So implicit differentiation just says then let's ddx both sides. So I'm going to do the ddx of x cosine y. What's the ddx of y cosine x? And then the ddx of 1. But again, notice on each of those over here on the left is a product. There's a product rule. So I got to do the first times the ddx of the second plus the second times the ddx of the first. Then I have to do the same thing here. First times the ddx of the second plus the second cosine x times ddx of the first. So those two turn into 4, if you will. Right? You got 2, so product rule twice. Each product rule has 2 of them. So anyway, all right. And then the ddx of 1, well, so far we've just had 0 on that right side. Okay, all right. Well, let's see. Okay, so now we need to figure out the derivative of those. What's the ddx of cosine y? Well, it is a y expression, derivative with respect to x, so note that, but I am just doing cosine. What's the derivative of cosine? Did you forget? Negative sine. Be negative sine y, but then I also have to put in what else? A dy dx, don't I? Because I am doing the derivative of x with respect to a y. Anytime you have that, this is going to show up. Then I have cosine of x, cosine of y. The ddx of x, that's just 1. Then y times the ddx of cosine of x. Well, the cosine of x again, so it's a negative sine, it's the derivative. And that one's just an x, so you don't need the dy dx there. And then last but not least, cosine of x, what's the ddx of y? Well, power rule-wise, y turns into just 1, but it's a y, so you still do need a dy dx right there. How's that look? Does that look okay? Anything troubling you there? I think we're good. All right. So let's write this a little more cleanly. We've got minus x sine y dy dx here. That would just be cosine y there. We've got a minus y sine x here, and then a cosine x dy dx. At the end there, equals 0. What do I have to do? Well, here's my dy dx terms. These do not have dy dx, so where do they need to go? Over to the other side. So minus the cosine y and add the y sine x to both sides. And that'll leave me minus x sine y dy dx plus cosine x dy dx is all that's left on the left, and then minus cosine y plus y sine x. Maybe probably switch those around, but either way. Then dy dx will factor out of that, these two over here, right? Leave me a minus x sine y plus cosine x, parentheses, equals negative cosine y plus y sine x. Then all that remains is divide by this, both sides. And I'm not going to write that twice. Let's save ourselves here a little bit. So it'd be minus, wouldn't it be minus cosine y plus y sine x divided by this parenthesis stuff here? Minus x sine y cosine of x plus cosine of x. Question or concern? All right. Let's take a look here at this one. Oh, yeah, let's go back to, all right, so we're going to find dy dx for the one I mentioned earlier. X cubed plus y cubed equals 15xy. That is the shape of that graph I didn't mention a while ago. It's called the folium of Descartes. It was the one that had the loop-de-loop. The folium of Descartes. You don't have to know that, but just FYI. Okay. But let's find for it dy dx. Slope of the tangent equation. Okay, well, yeah, this one, there's a couple ways I guess we could do it, but like we said, we can't really solve it explicitly for y. So our implicit is the way to go here, so we're going to ddx both sides. Well, we ddx the left side, it's just going to be the ddx of x cubed plus the ddx of y cubed. And then we're going to ddx the right side as well, and that's kind of where the complication comes in, because that derivative is not going to be 0 on the right as it has been. But let's see what happens if we do it this way. All right. Well, the ddx of x cubed is 3x squared, and it is just an x, so you don't need the ddx stuff anymore. The ddx of y cubed is 3y squared, but it's a y with respect to x, so that would need a dy dx, wouldn't it? Now, what am I going to have to do on the right? What rule must I employ there? Isn't it a product rule? Let's say it's 15x times y. Think of it that term. You could do however you want to, but yeah, that's two things multiplied together, so that one thing is going to become two things, isn't it? Product rule. So I have to do the first times the derivative of the second, or the ddx of the second, ddx of y, plus the second times the ddx of the first. So this comes out being 3x squared plus 3y squared dy dx equals 15x times, well, we've seen this one at least once before. Just the derivative power rule would be 1, but it is a y, so I need the dy dx there with that. And then here I have y times the ddx of 15x is just 15, isn't it? No dy dx needed there. So let's clean things up a little bit. 3x squared plus 3y squared dy dx equals 15x dy dx plus 15y, just to make it all nice and neat. Okay, what do you see happening, needing to be happening here on this one? Well, in this one, I've got dy dx's on both sides. Don't those need to be on the same side? So I'm going to bring 15x dy dx to the left, and all you'd have to do is subtract it. This one is not a dy dx, so it needs to go over to the other side. So I'm going to minus 3x squared from both sides. So all told, we'll have 3y squared dy dx minus 15x dy dx on the left, right? Because those are gone, so just have those two. Equals, that one's gone, so that one's, well, let's just say it's 15y minus 3x squared. Now we can pull out the dy dx over here on the left. So it'll be dy dx times parentheses 3y squared minus 15x equals 15y minus 3x squared. All right, now I'm going to divide off the 3y squared minus 15x because it's times the dy dx, and so if I can get that right here, dy dx equals that, 15y minus 3x squared over 3y squared minus 15x. There's a bit of symmetry to it there, doesn't it? A lot of times they do. Question? Anything about that? All right. Let's talk about this one. Find y prime for cosine xy plus x squared, whoops, sorry, I'll do that again. Cosine of xy equals x squared plus 3y. Find y prime. What do I do here? I'm trying to find y prime. I'm trying to do the same thing, okay? They may ask it different ways, but y prime is dy dx, using our usual notation. It's asking the same thing as we've been doing. It may ask it different ways. It may ask for y prime. It may ask for dy dx. It may ask some other way. This is, though, just looking for the derivative. And again, to do this derivative, can I get it y equals such and such x? I don't think so. Here's a y. Here's a y. If that y wasn't there, I could solve for y, but that y does complicate things quite a bit being in there. So no, I can't do it that way. Therefore, implicit differentiation, ddxing both sides, that's going to be the way to go. All right, so let's talk about that. ddx of cosine of xy. Then the d dx of this side would be the d dx of x squared, the d dx of 3y. With respect to x, okay? All right. The one on the left, what do you see? Hopefully you see some complications. Don't I have an outside part and an inside part? Yeah, that inside part there is not just x, not just y, it's xy. So, what does that mean? That means I'm going to have to use the chain rule on that. Chain rule says do the derivative of the outside, which is the derivative of the outside is the derivative of cosine. Derivative of cosine is negative sine. What happens to the inside when you do the derivative of the outside? Not a thing. Inside stays the same. But then I have to do the derivative of the d dx of the inside. So let me just write it this way for now. Because, and let's just mention here, what am I going to have to do the derivative of the inside? Product rule. Yep. So I'll save that for the next step. All right, d dx of x squared on the right, d dx of x squared is just 2x. The d dx of 3y is 3 dy dx. Because the derivative, just the power rule of y would be 1, but then it is a y, so you need dy dx. So I have minus sine xy times, said the derivative of the inside, we have to use the product rule. First times the derivative of the second plus, so let's just write d dx of y, and then the second times the d dx of the first. All right, so here's what I got. Minus sine xy times then, and that's all in parentheses. This is all together here. All right, so that would be x, the d dx of y. Well, just the y part, the derivative is 1, but it is a y, so I need dy. It's 1 dy dx. Let's just write dy dx. Then this, it's y, the d dx of x, it's just 1. So isn't that part there just y? Okay. All right. Lots of good stuff here. Now what? Well, I have a slight problem. Again, I have dy dx's on both sides, so I need to get them on the one side. Then I have the other problem. The dy dx here is in these parentheses with something on the outside of the parentheses. I think the best thing to do here is go ahead and multiply this inside. Because there's not any good way to get rid of that because of that dy dx on that side. So, yeah, I'm going to multiply this minus sine xy times these two, so I'll get minus sine xy times x dy dx, and then it'll be minus sine xy times y. See what I did there? Just multiply the minus sine xy times those. Now I can get the dy dx is on one side, and then the non-dy dx is on the other side. Can I do this? Minus sine. So if I bring this one over, here's what I have: minus sine xy, and let's go ahead and write that x right here. That x, let's write it in front. Usually, an x separate like that, you put it in front. So let me do that. Then I'm going to bring this term over. Well, it'd be minus 3 dy dx. So bring this term over here and then take that term over there. So it'd be 2x would be the term over there. Then if I add this sine xy, y, well, the y, let's just put it in front. Usually that's where you see it, because it can't go with that y because of the sine. All that being said, you with me? Okay on that? Did I do that okay? Now I can do factoring the dy dx off. So that would be minus x sine of xy. Whoop. Minus 3, if I factor dy dx off, equals the 2x plus y sine of xy. And then since that dy dx is times that, I would divide both sides by that. I'm not going to write it all 3 times here, so let me just say dy dx then would be 2x plus y sine of xy divided by this, minus x sine of xy minus 3. Does that look okay?